Hey guys, today we're going to upgrade the Cats API we made last episode by integrating a real relational database. This will be a big step towards production readiness. We'll be looking at the SQLDelight ORM, which is unique in that you write raw SQL and a code generator writes the mappings for you. Doing it this way helps keep you in tune with the underlying SQL, reducing the chance your app turns into a bloated monstrosity as it scales. Now let's get started. Okay, so last time we built a cat service that was using an in-memory data structure to save our application state. And while this is fine to get started, if we want to actually get to somewhere production ready, we're going to have to use a real database. Now in this case, I'd like to use a relational database, and we're going to be using the SQLDelight library. So we are going to go to the MySQL JVM section over here, and there's a couple things we need to do to get started. We need to add a plugin to our Gradle. This is going to handle the code generation. We don't need Google, but we do need to copy all of this over here. And are we going to change anything? Database. We change the package name to dev Andrew O'Hara .cats, and the dialect, MySQL dialect. Okay, that's fine. So let's import this. There's also one other thing that we'll need, which is this library that's going to bring SQLDelight into our application. Inside of our source main resources directory, I'm using the SQLDelight plugin, so it's suggesting some directories for me here. I'm going to do this, and inside here I'm going to make a cats.sq, and over here we're going to not only define our table but also the set of queries that we're going to be performing. So we're working with cats here, so we're going to make a cats table, and it's going to have an ID, which is a char 36, because UUIDs are exactly 36 characters long, not 40 like I thought last time. Whoops. And we're going to designate it as our primary key and can't be null. I actually don't know if not null is required when it's the primary key, but whatever, it doesn't hurt. The cats have a created @ which is a instant in Kotlin. So here we can use a time stamp, which will map to an offset date time. That's close enough to an instant, not null. We need their name, which we can do a varchar 128, I guess, or text, not null. Birth date, so this is just a date, so we can use the SQL date type. There's breed, which is another varchar or text. And color, which is another varchar or text. Okay, so we have our table, and now we can define some queries for it. So the simplest one is listing cats, where we're just selecting everything from the cats. Slightly more complicated here is getting a single cats. So we're going to be selecting all from cats where the ID equals a variable. Next is delete cat. So delete from cats where ID equals ID. And then there's finally create cat. Insert into cats and values. So first is ID. Actually, we could do ID created at, but SQLDelight is already smart enough. So all we really need to do is just give a bunch of question marks. 6 in this case. Yeah, and if we were to put 5 here, then our plugin here would tell us that's wrong. Now we can go and make a cats repo. assuming our build has run and the plugin has done everything it needs to do, which no errors just occurred there, so everything should be good. What it generated was a cat's queries object over here, which we're just going to call queries. And from here, we need to build our actual repository class. So fun list cats, which returns a list of cat. And this is going to be, so queries dots, and look, we actually have all of our operations that we defined inside that SQ file. So list cats, and we can do execute as a list, but this fails because we required a list of cat, which is our internal structure, but it gave us a list of cats, which is actually something that SQLDelight generated for us. So what we can do is we can create a mapping function over here. So we take the cats and we call it toModel, I suppose. And it's going to return a cat where the ID is the ID. And this doesn't compile because it requires a UUID but got a string. So in this case, we need to perform a conversion. And there are actually some amazing mapping functions you can integrate into SQLDelight to do this for you, but let's not get too ahead of ourselves right now. So all we really need to do is parse the UID, and that is it. So the name is the name, the created at is created at, oh, okay. So created underscore at from cats is an offset date time, but we can just very easily convert that to an instant. So that's fine. Date of birth requires a local date, and birth underscore date is a local date, so that's fine. So we just need the breed, which maps, the color, which maps, and that compiles. So now we can do this, and that compiles. We're going to reuse this. So inside our getCat function, we require UUID and returning a cat. And all this is going to do is queries.getCat, and we can see that it requires the string. So that's fine. So id.toString, and we have to execute as one or null. So we don't expect this to be there every single time. So we definitely want a nullable return value, but then we just call our .toModel and it maps to our internal structure. So that's great. We can do createCat, which takes not a data, because we want our business logic filling in the UID and the created time. So we're going to take an entire cat. Queries.createCat, where the ID is the cat's ID.toString. Birth date is date of birth. Created at needs to be an offset. So cat.createdAt offset, and I think you can do whatever offset you want, but the easiest one is just to do UTC. And the rest of the stuff maps perfectly fine. Oops, comma. Alright, and you'll notice that this createCat operation doesn't return anything, so we don't need to execute it, it just runs. Doesn't return anything either. Next is deleteCat, which ideally would return the cat, but let's see what the query gives us here. So queries.deleteCat doesn't return anything. Alright, well that's not the end of the world. And do we need to execute it? No, we don't need to execute it because it returns unit. Okay, so let's go over to our cat service. We're going to get rid of this data structure. And we're going to import our repository. And we need to upgrade our functions here to use it. So getCat is just delegating to getCat. ListCats is just delegating to the ListCats. And you may be wondering, what's the point of the service if all you're doing is just delegating calls to the repository? Well, it gets a little more complicated in delete and create. That's where it's useful to have that separation. So in delete cat, we want to be able to return the cat that we deleted. So we do get cat, and if it didn't return anything, we can just return null. And then cats.delete cat, and there. Okay, so we're no longer really able to tell whether delete actually succeeded in the background, but I don't think that's super important. And for create cat, the only thing we need to do is cats.create cat. And I might actually rename this to save cat, just to say that there's a difference between creating and saving, because creating is doing some other stuff with random, generating the UID, telling what time it is and all that. Does it compile? No, it doesn't. Well, we don't care about main right now. So let's just say that cats is equal to do. Does it compile? No, it doesn't. Okay, so we need to be able to pass the cats repo into our test here, which means we need a database. You could run MySQL or MariaDB in a Docker container for the tests, but I'd really rather not have tests depending on Docker being there and Docker containers coming up and down. We want our tests to be fast, not at the speed of Docker. So instead, I recommend another library. This one's called H2. Now, H2 is a pure Java database that can run in memory. So it's going to be really fast. And it also supports ANSI SQL, that's just plain SQL, but it also has compatibility modes for MySQL, Postgres, and whatever. So let's get it running. Oops, needs to go down there where you belong. Okay, so in our cats test, we need to create a H2 data source. So that is the JDBC data source, which I cannot find because IntelliJ. org.h2.jdbcx.jdbc data source. There it is. See, why was that so difficult? And we need to set its URL. If you're familiar with JDBC connection strings, this should make sense. Otherwise, I'm going to try to explain this to you. First, our URL is going to start with JDBC, and then the database driver, which is H2. And then we're telling it we want to work with memory. And then we're telling it we want to work with a different database every single time. And then we want to tell it when we close the data source connection, don't throw away that database. Now, the reason why we are giving it a random one and not just test is just kind of a quirk with H2. If we have multiple tests running, they'll try to reuse the same database, which has already been initialized. So with this, it ensures that we get a clean database for every single test invocation. That should be ready to go, but there is a bit of extra work required to get it working with SQLDelight. We need a database, which takes our data source converted to a SQLDelight JDBC driver. And then we can go and inject it into our cats repo, but not the database itself. See, the database has the cats queries that we actually want. Now let's see if that runs. Okay, it does not. And the problem is the table cats was not found. The database is empty. And that's because we never actually initialized our database. We created a reference to it, but we never actually performed the database migration. So data source.asJDBC driver, and with that driver, we can get our database schema and create it with the driver. And then we can pass it into our database. So let's run that. And done. Cool. Now we just need to get it to work with main. H2 was perfect for our unit tests, very fast. but you're not actually going to be using H2 in a real production database. You're going to be using like MariaDB, Postgres, MySQL, something like that. You're also going to be using a connection pool. First things first, let's get our connection pool. So Maven Central, Hikari, CP. If you're not familiar with connection pools, it's basically just a way to reuse connections to increase the performance of your app. So we have that. Now let's go over to main, and we need to create a config. Import com.zaxer.hikari config. It's just being dumb again. Okay, URL equals what? Well, we don't really want to be hard coding this stuff, especially the username and password. So this is where we might start to use environment variables. So system get env db URL. Okay, and then the username is going to be, I'm not sure yet what it's going to be, so that's a problem for later. And then the password is going to be another thing. And because Java doesn't tell you whether it's returning nullable or not, we're going to apply bang bang here so that if it returns null, we'll know. We have our database config, and we actually need to create the Hikari data source. And then we need to turn it into a JDBC driver. And just like before, we need to, we need to create the database. Only then, oh, that's an also actually. Only then can, only then can we create our database. And then we can create our cats repo where we pass in the database cats queries. And there we go. So this obviously isn't going to work because we haven't passed in any of these things. But let's get a head start over here. Let's create a run configuration for local. And we need some environment variables. Oops, these are here from my test run. Don't look. Alright, so db URL, JDBC, this time we're using MySQL. Let's just think ahead and assume that it's going to be on localhost 3306, which is the default database for MySQL, and it's going to be the cats database. Okay, so let's go and actually get a database here. We could either connect to one in our cloud, we can connect to one actually running on our computer, but it might actually be a little easier to just run one in Docker. Let's go over to Docker Hub, where we're going to use MariaDB, which is really just the open source version of MySQL. So it works perfectly fine, it's compatible with MySQL. And over here, it gives us a Docker Compose script we can use. So let's go and create Docker Compose.yaml. We paste that in and we check to see if this is everything we need. Well, so it's setting the password. It's also setting the adminer app up, which I don't particularly want. However, what I do want is to expose the ports. So we are taking port 3306 from the MariaDB container and exposing it to our local 3306. Now, when we run local, the database URL over here is actually correct. It's pointing to localhost to point to port 3306, except we need the cats database, because by default MariaDB is not going to create that for you. But what we can do is we can use this very helpful environment variable called MariaDB database, and it is going to be called cats. Okay, so now that is correct. However, we also need the DB user and DB pass. But we can see that this example here has already given us root and example. So we can just put those in. So DB user is root and DB pass is example. So let's try to run that. Okay. No suitable driver from Hikari. And that makes sense because Hikari is just our connection pool. It doesn't actually know how to speak MySQL. For that, we need the MySQL driver. So Maven Central MySQL, which is this. And so we put that into our build Gradle, and it actually can just be a runtime only because we never actually need to use it anywhere. It's just running in the background. So let's try that now. Okay, well, no error is good, I guess. Let's do a sanity test. Cool. All right. So this is fine, but all that did was just test listing the cats, which is hardly the most complicated query here, even though our test driver tested our queries against H2. I would just like to make sure that our Dockerized MariaDB is working as I'd expect. So this time we're actually going to use curl to post something to our app. So to create a cat, we need the birth dates, or is it date of birth? I'll find out later, I guess. Which is 2022-09-04. We need the name, which is my cat Kratos. We need the breed. Which is American Shorthair. We need the color, which is Lynx Point Tabby. And is that everything? I think so. Let's run it. Oh, do I need to do big X? Was that my problem? That was my problem. Okay, all right, we created our cat with that ID. So let's refresh here, and cool. Now just for sanity, we wanna make sure that when we restart our app, oh, what happened here? Table cats already exists. Yes. Okay, well that essentially confirms that we are using the same database over here. However, we get an error because it's trying to run the migration over here to create the cats. Now, migrations are a very complicated topic, which I considered covering here, but I think that'll be a later thing. But what we can do over here is we can update our migration. Create table if not exists. We're essentially pushing our problem to later. So let's restart that, and no error. And we refresh, and we still get our cat. Now, there is one thing we can do here, because you may have noticed that there's a lot of code that's slightly different between test and main here. It would be nice if we can create a unified factory method where we're just passing different configuration in, or different variables to create our app in slightly different configurations. So let's do that. Let's create a factory function. And what is required to create our app? Well, we need the clock, that varies. We need the random, that varies too. But we also need the environment. And Http4k actually has a really nice plugin that can help us with the environment. It's called Http4k config. So if we go over to core and we find config, there is a thing we can import over here. When we go back to our main function here, we can import an environment. And then this is going to return a cat service. And let's see how we're going to do that. So let's copy all this, move it there, return the cat service. So clock is going to be the clock that we brought in. The random is going to be the one that we brought in. And we need to replace these with the environment that we passed in. So HTTP4k config has essentially lenses that you can use for environment. So db URL equals an environment key, which is a string, and it is required. Then there is the db user, which is also a string, and it's required for prod, it's optional for test. So I guess we can see what happens if we make it optional. And then for our password, that is actually a secret, which we're going to make optional. So let's get rid of our system calls over here. We are instead going to reference our environments that we can pass in. So that's simple. That's simple, that works. Now, the DB pass is going to be a little bit different. It requires a string but found an optional secrets. Okay, well, how do we use it? With the use function over here. All we need to do is just take it, which is the decoded string, and then it passes it back to password, if it was there. Now, the reason why we have to do this is because once we use this secret once, it's cleared from memory, so it's a bit safer. So now in our main method over here, we can create our service where the environment is from our actual system env. The clock is the secure random converted to a Kotlin random, and then, sorry, the random is all that. And then the clock is our system clock. And then we can do service.toAPI and turn it into our running Jetty server. Now let's see how we can do this for test. Let's comment all this out and we'll create our service. So the environment is actually environment.defaults, where we can inject whatever parameters we want. So this is going to be JDBC, or we can just copy this actually. And then the DB user and DB pass were optional, so we're just going to ignore those. The clock is going to be this fixed one, and then the random is going to be our ultimate random seed. Okay. And that works. Now, yes, you'll actually notice we're not using the JDBC data source anymore. We're using Hikari, which has its own way of getting connections. Well, that's interesting. Let's run this and find out if it works. And not a problem. In fact, we can even get rid of the DB close delay flag and get rid of the random database name, and it should still work. Yes. Now, the only reason this actually happens though is because Hikari connection pool created a connection from H2, but rather than closing it every time it was done, it just kept it. And so if for whatever reason our tests require multiple connections to be opened, then this won't work anymore, because it's going to create a completely new instance of a database which isn't going to be synchronized with our existing one. And so I suggest we just leave that there. Let's see how main does now. Let's run local and no errors. And we're going to refresh this, and it is still working. So that was how we use a factory method over here to create just a single entry point to create our app with different configurations. The benefit here is that you're always creating the app in the same way. You don't have to worry about whether you're creating the right objects graph in both test and main. It's always the same objects graph. It's just different parameters going in. And that is pretty much it. That is how we use SQLDelight to bring a database into our REST API. So that's how to bring a relational database into your Kotlin API. There's many other options out there, but this is the one I wanted to show you today. Let me know in the comments if you'd like to look at a NoSQL database next, or if you'd like to jump forward to security or open API integration. And that's it. See you later.